Hello everyone. In this session, let us understand. Now, let me give you a complete idea about the locality of reference, what we have discussed in the previous session, from the programmer's perspective, from the programmer's point of view. Let us say, of course, you people do many programs, you people execute many programs as a day-to-day routine, right? You might execute a Java program or C program or C++ program. What kind of a program, whatever it is, you're going to execute many programs. Now let us understand the locality of reference concept from your programmatical approach, from a perspective of a program. Now I'll tell you that you wrote a program. Okay, you wrote a C program, that is which has 100 instructions. Okay, a C program, you wrote a C program which has 100 instructions. Okay, now here, if you want to execute your program, this, let us say this is your program. This is your program. Okay, if you want to execute your program, the fundamental rule of executing any program is all the statements in the program, rather all the instructions in the program should be executed at least for once, right? So all the 100 instructions must be executed at least for once. Okay, this is the fundamental rule of executing the program. That is, every statement within a program should be executed at least for once. Okay, but here the thing is, when you execute this program, there are a few localized instructions. Let us say there are instructions 6 to 20, rather 6 to 10. There are a few localized instructions will tend to get executed repeatedly. Okay, repeatedly. What is this? Try to understand. Let us say these instructions from 6 to 10 are a part of a loop. Got me? The instructions 6 to 10 are a part of a loop. Okay, so how many times the instructions from 6 to 10 will get executed? As many times as the loop gets repeated. And again, let us say from 20 to 25 is a function call, is a function. Okay, is a method or a function, whatever you call, that's a function. Okay, how many times the instructions from 20 to 20 will get executed? As many times as this function gets called. There is no restriction on the number of times that the function get called, from function can get called. So any number of times these instructions which are under a loop or which are under a function can be executed. Okay, so that is the thing of locality. This will translate to locality of reference. Okay, LOR, locality of reference, shortcut is LOR. What is this exactly? Let me tell you. Okay, now let us say I am accessing 23rd instruction. Okay, I am currently accessing 23rd instruction. This is my cache memory and this is my CPU. CPU will ask this cache memory, Mr. Cache memory, do you have this 23rd instruction? Cache memory, initially it will say no, because if the data item is being searched for the first time, this data element should not be present in the cache memory. So cache memory will say no whenever CPU is asking for any data element for the first time. Okay, so during which CPU is going to get the data directly, get the data element, let us say this 23rd instruction directly. Okay, meanwhile, according to the temporal locality of reference, this 23rd will also be transferred to the cache memory, right? Now, we know that in the instruction execution, the instruction that is going to be executed next is 24. Now, what is the point in sending 23 to the cache? Locality of reference says that if a data element, if a data word is accessed concurrently, that might also be accessed in the near future. But being a programmer, you can tell me that once after current instruction is executed, the next instruction that is going to be executed is the adjacent instruction to the current instruction, right? For that reason, what is the point in sending 23 to the cache? We need to send 24, right? So here the problem is, rather, the thing that you need to understand is 23rd will also be sent to the cache anyhow. Why? Because what if this 23 is a part of a loop? What if the 23 is a part of a loop? Okay, loop will have to re-execute it again. So at that time, if the 23 is not available in cache, again we are going to experience a miss. Okay, if the information is available in the cache, CPU will take no time to read that. If the information is not available in the cache, which is called a miss, CPU will have to read the data from the main memory, which takes a lot of time. So for that reason, even the currently accessed data element will also be transferred to the cache memory for the future references, because it might be a part of a loop. Okay, rather it might be part of an array in which it will get accessed again. Okay, but you know that when it comes to the spatial locality, of course, the spatial locality exactly justifies the program what we are executing right now, because when you execute this instruction, obviously next instruction will get executed. At that time, if you send only this instruction into the cache, next instruction will face a miss, will experience a miss in the cache memory. Again, next instruction will experience a miss. So rather than sending only the currently accessed element into the cache memory, a block of data elements will get sent to the cache memory for the future references. Because when a data element has been accessed concurrently, all the data elements, in addition to the currently accessed data element, which are a part of a group or a block, might also be accessed in the near future. For that reason, we will have to send a complete block of instructions or words when they are accessed to the cache memory for the future references. This is all about locality of reference. Okay, this is what all about locality of reference. Thank you.